Let us find out the unit of magnetic field. Magnetic field, it's given by the letter B. It is a vector quantity, B vector. See, so far we have seen the magnetic field, but what is its units? See, we have seen the Lorentz force. What is the Lorentz force? Lorentz force. This is the force which is given by the magnetic field on a charged particle when the charged particle is moving in its magnetic field. So Lorentz form in vector form, we can call it as a magnetic force is equal to charge into V cross B. See, where V is equal to velocity of the charged particle, B is the magnetic field in which the charged particle is moving, Q is the charge of the particle. So in scalar form we can write Fm in scalar form, or simply F is equal to Q into V into B into sin theta, because this is VB sin theta in unit vector. So Q into its scalar, Q into V sin theta, where theta is equal to angle between the velocity vector and magnetic field. That is the value of theta. We have seen the theta. So magnitude from here we can write, see, from F, since F, or we can write this has got no unit, sin theta, so we can remove it, or we can write B is equal to F divided by Q into V. We know current is equal to charge flowing in a unit time, that is charge is in coulomb per time is in second, or C is equal to I into S, or unit of charge is coulomb in A into what is this, A into S in SI unit, where C stands for charge, where C stands for the unit of charge, I stands for current, this is for second, a unit of current is in ampere and time is in second, coulomb. C is equal to A into S. So from F is equal to, from B is equal to SV, from this equation, the unit of B, the unit of magnetic field B is same as the unit of F by Q into V, because by dimensional analysis this unit should be is equal to this unit and its dimension should be is equal to LHS dimension should be equal to RHS dimension, where F is equal to force on charge, that is charged particle, and Q is equal to charge, Q is equal to charge, G velocity of the particle moving in magnetic field. So we want to find out B. So force is in Newton, in SI unit is in Newton, and charge what is? Charge is equal to current into time, and velocity is in meter per second, or you can say ampere into second. We can write it like this, charge. So we are going to substitute it in current and velocity is in meter per second. So what is the unit of B? Now we are finding out in SI unit. First let us find out in SI unit, as later we will find out in CGS unit, as the CGS unit is generally not used. So we can say the unit of B is force. What is force? Force is in Newton. What about the charge? Charge is equal to F divided by charge. Charge is equal to ampere into second, and velocity is in meter per second, and cancelling this one, this equal to Newton ampere meter. So unit of B is ampere, unit of B is ampere per meter in SI unit, in this SI unit. So what we call in this, call this, or we can say N divided by E, N divided by E, that we call it, now we call N divided by E, that is unit of magnetic field in SI unit is known as 1 Tesla. Tesla, name of the scientist who invented it. So we can say 1 Tesla is equal to, it is represent 1 T is equal to 1 Newton ampere divided by ampere turn meter, or we can write like this, Newton ampere meter. This is not minus, multiplication, ampere meter. So this is the unit of 1 Tesla, that is 1 Newton per ampere meter is called 1 Tesla, and it is SI unit of magnetic field. Okay, now what about this dimension? Let us find out the dimension. See, this is dimension, a dimension of B. See, Newton is in what? Newton is in, let us write, Newton is in kg meter per second square, because force is, Newton is, this is, Newton means force is equal to mass into acceleration, that is meter per second square, and divided by ampere. Charge, what is the unit of charge? The unit of charge is equal to A into S, because Q is equal to, what is Q? Q is equal to I into T. I into means ampere seconds, that is ampere second, and velocity is in meter per second. This we can write as kg meter per second square into second per meter into 1 by ampere second. So it means we can cancel this and this, and this and this. So this is equal to kg s minus 2 into A minus 1. Kg means m, mass, and time is t power minus 2 a power minus 1. So the magnitude of this is equal to, magnitude of magnetic field is equal to m power 1 t power minus 2, where t stands for time, into e to the power minus 1. This is the dimension of magnetic field B. Now we will discuss about CGS unit also. What is in CGS unit? The unit of magnetic field is called. In CGS unit, the unit of magnetic field is Gauss. In CGS unit, unit of B is Gauss. Here do you CAU, that is we can write it as Gauss. So it means here it is in Tesla, in SI unit it is in Tesla, SI unit it is in Tesla, and CGS unit it is in Gauss. And what is the relation between Gauss and Tesla? See, one Gauss is equal to 10 to the power 4 minus Tesla, or we can write 10 to the power 4 Gauss is equal to 1 Tesla. 10 to the power 1 Gauss is equal to 10 to the power minus 4, or 1 tau, or 1 1 Tesla is equal to 10 to the power 5 gas. So Tesla, that is unit of Weber, which later we will be seeing it is in Weber per meter square. Then we see the magnetic flux, that time we will come to know Weber per meter square. So you can write the gas, that is unit of magnetic field is Tesla, which is equal to 10 to the power 10 to the Tesla, which is equal to 10 to the power 4 gas, which is equal to Weber per meter square, or we can write all the combined together. The unit of B is equal to Newton ampere per meter, which is equal to 1 Tesla, which is equal to 1 Tesla is equal to 10 to the power 4 gas. 1 Tesla is equal to 10 to the power 4 gas, or 1 gas is equal to, the difference is this, my 10 to the power will come down, it will go to the numerator. So this is, we should not suppose why we are talking about this. Whenever we are given in the numerical, it can be given in any unit. So we should be able to recognize in which unit it is given.